Okay, the last part of our lesson is just a little bit of the first part is shifting left and right, and then the rest of it is a little bit more entailed. So 30 seconds on horizontal shifts. What do you think would be the effect of adding a constant inside the parentheses? So before, with the vertical shift, it was outside the parentheses, as you can see with this D over here. That's outside the parentheses. That goes up or down. Now, on the inside of the parentheses, you may remember from transformations, when you have this, it goes up. And if you have this, it goes down. But when you have the C inside the parentheses, it goes left. And when you have it on the inside of the parentheses, but it's a minus, it goes right. Remember, what's inside the parentheses was always the opposite of what you would think. Okay, so what this does here is it goes left, and then for the sine function, it goes right. Okay, so that's the 30 seconds on horizontal shift. Now we go on to the final transformation that we're going to be doing, which is horizontal stretching and compressing. It's important to be able to do this, especially when you're modeling real world phenomena, because most periodic functions do not have a period of just 2 pi. Okay, so this is going to compress it horizontally and stretch it out horizontally. So first, we have to remember what a cycle of sine and cosine looks like. So a sine function starts on the origin, and then it goes up to 1 and then back to 0 and down to -1. That is one complete sine cycle. Whereas the cosine starts at a +1 instead, and then it goes down and goes back up. That is one complete cycle. Notice that it took an interval of 2 pi to complete one cycle. Okay, and the same thing for cosine. In order to complete one cycle, it took 2 pi. That is the interval. That is what is called the period. Okay, the interval to complete one full cycle. Okay. Okay. So let's see what we have down here. Here on the grid, we have the graph of h of x. And h of x is equal to 3 cosine of x. Okay, so we know that the cosine of x has a range of just -1 to 1, but this is 3 cosine x. That's the amplitude, which means that that is the height. Okay, so we have the midline. The midline goes right through the middle, kind of like the axis of symmetry, except it's really not symmetric, but right through the middle. Okay, and we have 3 above and then 3 below. Okay, that's where that 3 comes from. Okay, so now it says to use your calculator to sketch the graph of y equals 3 cosine 2x. Now, if you remember, when we have f of 2x, whatever that function is, when the 2 is on the inside, remember when the 2 is on the outside like this, that was the vertical stretch. But when it's on the inside, it's the opposite. So this is a compression, all right, a compression. So we're moving or compressing toward the y-axis. So we're pushing it in further. So it says to do this on your calculator, so we can just go ahead and do that. All right. So if you were to put in y equals 3 cosine 2x in your calculator, and then you're looking to see where it is. Now the range hasn't changed, right? So I'm going to start from my y-axis. And then if you look in your calculator, at the first quadrant, you're down at -3. So here's the first quadrant, and you're already down at -3. All right. And then in the second quadrant, when you get to the second quadrant, you are back to the x-axis. Okay, and then you keep on going. 1, 2. Actually, you're not on the x-axis. I'm sorry, I'm a little distracted because there's a stink bug flying around in the room, and my cat is jumping up and trying to go after it. I think I'm going to pause for a second and try and fix the situation. Just a second. Okay, sorry about that. I removed the cat, but I can't find the stink bug. So let's continue anyway, though. All right, so looking at on the calculator, when you are in the second quadrant at pi radians, you are back up at 3 again. And then when you are at 3 pi over 2, you're back all the way down to -3. And then at 2 pi, you're all the way back up. So let's take a look at what just happened. Okay, so that's what it looked like on that side. And I'm just going to leave it at that for a moment. So now what you should be able to see is that in 2 pi radians, you have 2 full cycles instead of just 1. Okay, so let's take a look at that. This is 1 cycle and then 2 cycles. That's where that 2 is coming from. Okay, and that's such an important part of it that it has its own word. That is called the frequency. Okay, and the frequency is the number of cycles in 2 pi. Okay, so in this case, there's 2 cycles, but you get that from that compression. And you can do the same thing on the other side, which I'm not going to bother doing. Okay, so how many full cycles or periods of this function now fit into 2 pi radians? That would be 2. All right, using your calculator, sketch the graph of 3 cosine 1/2. So now instead of a compression, this is going to be a stretch, a horizontal stretch. Okay, and I know that the frequency is equal to 1/2. Which means that's the number of cycles in 2 pi. So that means there's only going to be 1/2 of a cycle in 2 pi. Okay. So let's take a look at that, what that's going to look like. All right, so let's pick a different color here. We'll pick green. Okay, so now in your calculator, go ahead and put y equals 3 cosine, but instead of 2x, we're going to change that to 1/2 x. All right, and then go ahead and graph it. So now when you look at that graph, again, on the y-axis, you are still starting at that same location. But when you get to pi, you are on the x-axis. And 2 pi, you're all the way down at -3. So you can see that that's half, right? Half of the cycle. The rest of the cycle you could go ahead and put on the other side, and then you can see the full cycle, but it takes 4 pi to complete that full cycle because there's 2 pi on this side and there's another 2 pi on that side. So it takes 4 pi to complete a full cycle. That's the period. Okay, so how many full cycles or periods of this function now fit into 2 pi radians? So now it's just a half. All right. So the period, we just spoke about that. The period P of a sinusoidal function is an extremely important concept. It's defined as the minimum horizontal shift needed for the function to repeat its fundamental pattern. Okay, so the period for the basic sinusoidal graph is 2 pi. Clearly, from our first exercise, the period of the function depends on the coefficient b in the general equation. So the period is not given in the function, but you can get it from the equation because it is has a correlation to the frequency. Okay, that b is called the frequency. So again, note the difference between the two. Okay, so I'm just going to define these one more time because this is a problem normally in the classroom. Students don't understand the difference between frequency and period. So frequency is the number of complete cycles in 2 pi, okay, in that interval of 2 pi, whereas the period is equal to the interval it takes to complete one cycle. Okay, so here, let's take a look. We have y equals 6 sine 10x. Okay, so I know that the frequency is 10. That b value is in our equation. So for all of these, we can go right in and say, okay, well, that's 8, and that's 1/3. Okay, but how do we find the period? So if it's completing 10 cycles in a 2 pi period, that means that 2 pi divided by 10 would be the interval for one cycle, right? Or you can say 1/5 pi or pi over 5. That is the period. That is the interval it takes for one cycle, because 10 of them would then continue, and then you would have 2 pi. All right, so this would be 2 pi divided by 8, which is 1/4 pi, or pi over 4. That is the period. And this is just 2 pi divided by 1/3. Don't let that trip you up. Okay, remember when you divide fractions, it's multiplying by the reciprocal. So instead of dividing by 1/3 is the same as multiplying by 3. So that would be 6 pi. Okay, if it only completes a third of the cycle in 2 pi, then it would take 3 times that, okay, in order to complete a full cycle. So we can see that the frequency and the period are inversely related to each other. As one increases, the other decreases, and vice versa. Now, if you look at the period first, okay, so the period is equal to 2 pi divided by the frequency, and the frequency is equal to 2 pi divided by the period. All right, that's what it means to say that they're inversely related. Sometimes when you look at a graph, it's easier to find the period, and sometimes it's easier to find the frequency. Okay, so I'm going to have you go ahead and do this practice and see how you do. All right, I'm just going to look a little bit though. Notice that the first thing you always want to do is draw the midline. So I'm just going to start you off here, and the midline is halfway between the maximum and the minimum, and I hear that stink bug buzzing around again. Okay, so I'm going to draw that first, and that's my midline. And then I'm going to go here. Okay, so you kind of draw a crossbar. Okay, and then you can kind of see, okay, if my cycle starts here, when does it end? That's a complete cycle. Okay, and that's what you're going to want to do for each of them. So you can see what the period is here, and you can see what the frequency is pretty easily. Okay, the next one, when you're looking at the midline, it's between 0 and 3. So it would be at 1.5 would be the midline. So again, you draw that crossbar, and then you're looking at that is one complete cycle. So you can see what the period is right there. If you want to see how many cycles are in 2 pi, you would just keep on going until and count. This is 1, and then this is 2, and then this is 3, and then this is 4. Okay, but once you get 1, you can go ahead and determine the other because it's just 2 pi divided by the other one. Okay, happy practicing. This is the last of the lessons that I will be able to share with you. I have enjoyed it tremendously. I hope you did too. I hope you learned something. And I love you guys and keep in touch. All right, bye-bye.